Welcome back, students. Today is the Q&A session 7 from the chapter of motion in a straight line, and the question is, a train is moving with uniform acceleration. Its engine crosses a pole with a velocity of 60 km per hour. The last van passes this same pole with a velocity of 80 km per hour. The last van means the last bogie of the train. The last bogie of the train passes the same pole with a velocity of 80 km per hour. It is that bogie in which the guard is stationed. The middle point of the train will pass through the same pole with a velocity of. Now there are 4 options here, and we have to find the correct one. So let us consider this is a pole. This is the train. This is the engine. And this is the last bogie of the train. That is that bogie in which the guard is stationed. So its engine crosses the pole. This is the pole. So the engine of this train crosses this pole with a speed of 60 km per hour, and the last van, that is the last bogie of this train, crosses the same pole with a speed of 80 km per hour. The train is moving with a uniform acceleration. So in this case, I can use the equation of motion, that is v square is equal to u square plus 2as. First thing. Second thing is here, in this case, the initial velocity u can be taken as 60 km per hour. V, that is the final velocity, can be taken as 80 km per hour. A is the uniform acceleration of the train. Uniform acceleration of the train, and S is the length of the train. So this is the equation of motion where u is the initial velocity, v is the final velocity, a is the uniform acceleration, and s is the distance covered. So here u will be equal to 60 km per hour, v will be equal to 80 km per hour, a is the uniform acceleration, means the train is moving with the uniform acceleration, so I have taken that uniform acceleration as a, and the distance covered will be equal to the length of the train. So this is the length of the train, and I have taken this length of the train as s. So from this equation we can write that 2as is equal to v square minus u square. Okay, and this can now v is equal to, so this can be equal to 80 square minus 60 square. So it implies that s is equal to 80 square minus 60 square will be equal to 80 plus 60 into 80 minus 60. That is a square minus b square is equal to a minus b into a plus b. So that is equal to 80 plus 60 into 80 minus 60. This is equal to divided by 2a. So s is equal to, that is equal to 140 into 20 divided by 2a, and that can be written as 1400 divided by a. So the value of s is equal to 1400 divided by a. Now we have to find the means the question is the middle point of the train will pass the same pole with the velocity of. So s is the length of the train, so the middle point of the train will be equal to, it will be just half of it. So I'm just writing here that s is equal to 1400 divided by a. So I'm just writing this s is equal to 1400 divided by a. Now the middle point of the train will pass through the same pole with a velocity of. So these are the 4 options here. So the middle point of the train, this s is the length of the train. So the middle point of the train will be equal to S by 2, which is equal to 700 by A. Okay. So now again, I will be using the equation of motion, that is V square is equal to U square plus 2AS. So in this case, we know we have the value of U is known to us, and in this case we have to find the velocity, that is the middle point, the velocity of the middle point of the train when it passes the same pole. So U is known to us. So V square is equal to U square. U square is equal to 60 whole square plus 2 into A into S. Now S is equal to this. S is the distance covered. So in this case, that is in this case, the value of S will be equal to 700 divided by A. The middle point of the train is, this is the length of the train. This was the length of the train which we have taken as S. So the middle point of the train will be equal to S by 2. So S by 2 was equal to 700 by A. So by using this equation of motion again, that is V square is equal to U square plus 2AS. So in this case, U is equal to 60 km per hour. The middle point of the train, that is, let's say this is somewhere here. So this distance will be equal to S by 2, and that S by 2 was equal to 700 by A. So that I have put that value here. That is S is equal to 700 by A. So and A is the acceleration of this train. So V square will be equal to 60 whole square plus A will get cancelled out, and this is equal to 1400. So V square is equal to 3600 plus 1400. So this is equal to V square is equal to 5000, or we can see that V is equal to under root of 5000. So this is equal to 10, that is 5000 can be written as 100 into 50. So this is equal to 10 root 50, and the value of this root 50 is equal to, if I just take the under root of this will be equal to 10 into 7.07. This is the approximate value. So V will be equal to 70.7 km per hour. So the middle point of the train will pass the same pole with a velocity of 70.07 km per hour, and so our correct option is the second option, that is the option B. So in this case, we have used the equation of motion, that is V square is equal to U square plus 2AS twice. In the first case, we have by using this equation of motion, we were able to find the relation between the length of the train, that is S, and the acceleration of the train, which came out to 1400 divided by A. Now the middle point of the train will be equal to S by 2. So again, by using this equation of motion, that is V square is equal to U square plus 2AS. So what I did that, the middle point of the train is equal to that is s by 2, which is equal to 700 by a. So I just substitute that value in this equation. A is a uniform acceleration, u is 60 km/h. So I was able to find the velocity of the middle point of the train when it passes through the same pole. So the answer is 70.7 km/h, and the correct option is B. So thank you very much for joining this session. In the next session, I will begin coming up with the another type of question. Till then, have a nice day. Bye.